Today we are working on day 3, which is area, circles, sectors, and what we call segments. Yesterday our focus was on circumference and arc length because that was part of the circumference. Today, as I said, our focus is a little bit different, but hopefully you're going to notice some similarities. So the first thing they want us to do is find the area of each shaded region. We know our formula for area is pi r squared, and we're going to leave everything in terms of pi. So I believe that's a 5. So the area of that first circle is 25 pi. The second one, we have to go and find the radius, which is half of our diameter. Now, on 3 and 4, they start changing it up a little bit. If you take a look on 3, we're not looking for the area of the whole thing, we're looking for half of the area. So we're doing 1/2. We have to find the area as though there was a full circle. So that diameter, or excuse me, that radius would be 2. So we have 1/2 of 4 pi, which means the area of this region is equal to 2 pi. And think about that 1/2 for a moment, and think about how we related it yesterday as well. Again, we can visibly quickly recognize it's 1/2, but if we couldn't, using the same philosophy we did yesterday, that 1/2 is 180 degrees out of 360, which again reduces to 1/2. So again, if it's a quick visible one, we can get to that 1/2. If it's not, same concept as yesterday. We're doing degree out of 360. So keep that in mind for this next one. If you look, my whole entire circle, first of all, would be pi times 8 squared, which is 64 pi. But if you take a look, I'm not looking for the whole entire circle. I just want 1/4 of that, which ultimately gives me 16 pi. Notice again, I gave you a quick visible fraction of 1/4. But if I didn't give you one that you could visibly get, think about how we would do this applied to yesterday. I would have 90 out of 360, which again reduces down to the 1/4. So we already know our formula for area of the circle is pi r squared. The area of the sector is exactly what we did on numbers 3 and 4. We are looking for part of the area. And how do we figure out that part? We take our degree divided by 360 and we multiply it by the area of that circle. And again, let's kind of give you a visible picture of what we're talking about. When we're looking for the area of the sector, we're essentially looking for a slice of the pie, or a slice of your circle. This last one, area of the segment, I'm going to give you a visual and we're going to come back to the formula here in just a second. So let's take a look. An area of a segment, you start off with a slice of your pie and then we subtract this piece right here. What we really want to end up with is just that leftover piece up in there. So in other words, we are finding the area of the sector and we are subtracting the area of the triangle. So our formula for area of a sector was right here. It was the degree over 360 times pi r squared. The area of the triangle, you've got a couple different formulas. Your most common one is 1/2 base times height, but I'm also going to introduce / refresh your memory. There was one other formula that we roughly saw in the last unit. It was 1/2 BC times the sine of A, and I'll go through that a little bit more for you shortly. All right, let's move on to question number 4. They want to know how much more pizza is a 14-inch diameter than a 12-inch diameter. If we're talking pizza, we are talking area. So we want to compare the 14-inch area to the 12-inch area. Our formula is sitting right here. We've got pi times 14 squared minus pi times 12 squared. This is 196 pi minus 144 pi. 196 minus the 194 would give us 52 pi. Doesn't really say whether it wants exact form or to a decimal. If it said exact, we get to leave it in this form. If it says it wants it to a decimal, we're going to go ahead and type in that 52 pi. And I end up with 163.4 inches squared. Okay, moving on to number 5. A circular archery target has a 2-foot diameter, so let's go over here. This is 2 feet. It is yellow except a red bullseye at the center. Notice this is inches, this is feet. So let's go ahead and change this to inches. So 2 times 12 would give us 24 inches. And I'm thinking I better draw my picture a little bit bigger. Here's the bullseye. It has a diameter of 6. This one had a total diameter of 24. Find the area of the yellow region. So if you can picture, what we're looking for is this area out in here. Right away we know its area. We've got our formula up there, so we want to look at the area of the whole thing, and it has a diameter of 24, which means its radius is 12. We're going to subtract the area of that red circle, which again has a diameter of 6, which means its radius is 3. So 144 pi minus 9 pi. I get 135 pi, but again it says to take it to the whole number. So 135 pi gives us 424.1 inches. Okay, 6 and 7, so these two up here really focused on just the general area of a circle, but some applications. 6 and 7, notice we're looking for a slice of the pie. That means we're looking for part of the area. So again, we're doing part times area. Well, the part that I'm looking for is 8 out of 360. My area in this case would be 144 pi, because 12 squared is 144. We're going to set that pi to the other side. I'm taking 80 times 144 divided by 360, and I end up with 32 pi. Same thing on number 7, or the second part of 6. Part times area. In this case, I want 45 out of 360. My area is 121 pi. Up with 15.125 pi. Okay, moving on to the back side. So here's the last formula that we're going to take a look at, and we put this on the front. The area of the segment we said is the area of the sector minus the triangle area. And I pulled off 2 examples from your textbook that kind of walk us through play by play. So if you look at number 3, what we're finally looking for is this region up in here. So we're going after the area of the sector. Again, we're looking for the degree over 360, which in this case is 120. And we are plugging in, our formula is pi r squared. We're going to go ahead and substitute in this case, 24. So we get 120 over 360, or if you want, that reduces to 1/3, and we're doing 1/3 of that 576. And we get 192 pi. Okay, step 2, now we're looking for the area of the triangle, and we'll try and go through 2 ways for you. They're suggesting we use the 30, 60, 90. So our hypotenuse in this case. Okay, rethinking this. We're going to make our life a whole lot easier. We're going to go use that other formula. It's area equals 1/2 BC times the sine of A. Notice these are lowercase. They're talking about the sides of the triangle, and big A is talking about the angle itself. So if you take a look at this triangle, we have 1/2 of 24 times 24 times the sine of 120 degrees. Again, I'm focusing in on this triangle. If this is 24, the other radius is 24, and the angle I'm looking for is in here. I'm going to plug that directly into my calculator, and I come up with 249.4 for the area of the triangle. And that will be the main formula that we're going to use because it's going to work every single time. So finally, we got to take the area of my triangle, the area of my sector, which is the 192 pi, and we're going to subtract the area of the triangle that we got to be 249. So 192 pi is 603, and I can actually type it in exactly how I see it. 192 pi, put my calculator on here for you, and I'm subtracting 249.4, and we eventually get 353.4. So I've got a few minutes. I'm going to go and hit one more of these on your homework assignment. We are on day 3. I'm going down and I'm taking a look at number 6. So again, we're going to do sector minus triangle, and that will give me my final answer. So my sector area, again, is 90 over 360 times, in this case, 64 pi. When I plug that in, I eventually get 16 pi. I'm going to subtract the area of the triangle. I'm going to use that same formula, 1/2 BC times the sine of A. So in this case, my B and C are both radii of that triangle. They're both the same, 8, and that angle in between them is 90 degrees. When I plug that in my calculator, I end up with 32. So we have 16 pi minus 32. Again, this is my exact answer, but it wants it to the nearest 10. So I'm going to plug in exactly what I see. I see 16 pi minus 32, and we end up with 18.3. I will see you back in class tomorrow. Do the best you can tonight, and I will get those answers posted for you later.